We have Jim O'Leary from Facebook to give us a talk about security selfie, or hashtag security selfie. I need to say that part, don't I? Thank you for your consideration.
Very nice. We good? You can hear me? I can hear myself, so you can probably hear me too. Perfect. So thanks for coming out. Welcome back. Welcome back from lunch. My name's Jim. I work at Facebook. And I'm here to essentially maybe start some conversation around measuring the beautiful craft that is software security engineering. I've been finding bugs in code for a long time, and then I've started fixing bugs in code. And now I'm more about preventing bugs in code from ever making it into the code base in the first place. So if you kind of bear with me for 30 minutes or so, I'll show you some existing work that's out there, right? Like this isn't a new field for sure. Like people have been measuring things for a long time. People have been securing things for a long time. I'm hopefully going to give you a little bit of like a newer twist on it. And if, like I said, you bear with me for 30 minutes, I'll give you this one hot trick for securing your code base that you may not realize is super effective and also really easy. And every talk I've been at so far today, people have been like raising their hands to get started, so I'd like to do the same thing. Raise your hand if you know what KPI stands for, and shout it out if you're feeling super feisty. All right, key performance indicator. I'll tell you in full disclosure, I gave this talk at appsec, California, and I was kind of disappointed by the following question here. But PKI, raise your hands again. Oh, my people. Yeah, so public key infrastructure, one of the core fundamental building blocks of modern security systems. To be honest, I gave this talk before, and I was like, KPI, like a whole bunch of hands went up. And PKI, and like nobody said anything. And I was like, this is perhaps the wrong audience for my talk. OKR, how about this one? All right, one more time. I'm really soliciting the input from my audience here. How about this dude right here, OKR? All right. And so with all this kind of like management gobbledygook, at some point beyond all this, you're going to want to have your code or your code base or your systems telling you like how they're doing. Like it's the work that you're doing, producing any meaningful output, or are you just doing all this exercise because like you can do it? So to bring it to some numbers, right? Like in the world of security, this is sort of what we're after all the time, right? Like zero, the absence of value. Did anything terrible happen today? How many bugs are in the code? How many employees are phished? How many of my laptops got compromised? Eventually, like it all comes down to like you sort of want nothing to happen, and then you've won. So my homeboy, Alex, he's over at Clever doing security. Put together this nice template for you all to use. This is one of my contributions back to you, the audience. But if you're writing security OKRs, be like, all right, we'll protect from every possible thing that could ever go wrong. And if this all goes well, I'll have nothing to show for it. And things will fail by virtue of this number, right? So it's the other side of the binary bit flip. It just takes one person to find one thing to like undo all of the hard work that you've done leading up to this point in securing your code bases. So this is the kind of phenomenon of attacker asymmetry. You get one of the other speakers here finding all these like sweet O-days and stuff. They just need to find one, and then you lose. So to move beyond this like binary nature of security work, there's got to be more than a simple pass-fail grade at the end of the day. And I'll bucket what I consider like security engineering work into three main buckets, and why some are more enjoyable than others. So reactive is what I find to be the most exhausting work. This is where something has shipped to production, you've become aware of it, and you need to scramble to patch it because it's either publicly known or is actively being exploited. Proactive is when you've done enough firefighting that you stop and you say, it would be really great if we found these things ourselves before they started getting exploited in the wild. So this is where you might go and engage like a third-party pen tester or start doing security reviews of things yourself before they ship. And lastly, like just mitigating work, right? And so this is the class of work where you're going to realize that you're still going to have issues in your production code base. It's a byproduct of software development. But you do some work to make all these issues less bad when they actually happen. So I mentioned these like vulnerabilities. You could go do something like, if you're in a services-oriented architecture, do some jailing or firewalling, segmentation kind of stuff, so that if something breaks somewhere, it doesn't explode and everything falls apart around it. I submitted this abstract before I had really done a lot of the work, and so it got accepted, and I was like, well, I should probably start reading about security metrics as a result. So this was my nightstand for a little while. And one piece of feedback I heard from this talk when I gave it internally at Facebook and a couple other places is that the abstract makes it seem as if I'm going to be like, here is all of the KPIs that you can just copy paste into your application security program and you'll be fine to run. And that's not how I'm pitching this thing at all, actually. If you're interested in that, this book with the frog on it is actually really good at like giving you a whole bunch of template KPIs and all these kind of things. This book on the left with the big hand on it and the beginner's guide is really good at giving you a broader perspective on like what security metrics mean. I work on the product security team, so I'm really focused on the security of code. This is stuff like traditional OAuth top 10 or knocking out the buffer overflows and all this kind of stuff. So I'm more focused on appsec, and what I'm about to unveil a little bit later on is more of an appsec focus. But we fly through these really quickly. Kind of 3 existing systems that are out there that you might be familiar with. Microsoft has a history of producing software, not the most secure software for a little while there, but as a result, they put together this secure development lifecycle and then release it to everybody as well. So if you can learn anything from Microsoft of the early 2000s, it's something like how to take a software package from the very beginning, go through development, testing, release, all these sort of things, and hit milestones along the way, right? So it's kind of like you threat model, and then you run some static analysis, and then you do some like manual testing, and then you release it to production. So check that out if you've not done so already, and kind of like take the best parts of that and apply it to your security program. The BSIM is the Building Security in Maturity model, and this is a collection of stuff that other people are doing to secure their code bases. And so don't treat this as a checklist either. Kind of go check it out. It's like a 70-page PDF when you download it, so pour yourself a nice brandy, put your smoking jacket on, and enjoy Saturday evening with the BSIM or something like that. But take it, pull out all the good parts, and then use that to build out your security program as well. And then there's this Google Chrome Health notion that Parisa from Google gave a talk about a little while ago about the parallels between the human health system, like you go to a doctor, they check you out on these different axes, and then similar, like the mapping to the Google Chrome security space, right? So it can be stuff like how long it takes you to patch a critical vulnerability that gets reported. Like that's just a metric that by itself doesn't really mean too much, but is a good kind of like parallel for how you're doing overall. So check these 3 things out. The other issue with these though is that they're like a giant, not necessarily checklist, but they're a big list or a collection of things that you need to do. And there's no good sense of priority. Like, should I be threat modeling or should I be investing more in like moving everything to a more secure stack, or should I be spending all my money on static analysis, or should I be hiring the world's awesomest hackers? Should I start a bug bounty? What should I do? And so there's no kind of like collective measurement for how you're doing all this work and if it's actually moving the needle, as they say, in any positive or negative direction. So I made some campaign promises in my abstract that I will be loosely upholding, right? So the first of which is that, well, let me see here. I'm inspired by a modern marvel of our time. I call this the selfie. And this is the photograph taken by a person who is also in the photograph. And I cite this because I want to use data that you might not realize you already have. So the nice thing about this thing about the pitch to everybody is that there's like no work involved at all, and you end up with a thing that tells you how secure you are. That's because if you're doing any software development or engineering, like you've got bugs, and you're measuring the bugs somehow, you're tracking them all, and you can take what you've got in your overall like engineering process and then map that to how you're doing on the security side of things. And so one of my first maybe scientific principles here is this spectrum of badness. And it kind of starts like in the early development life cycle, right? Like you've got an engineer who sits down and he or she are about to go commit the worst security mistake of all time. And it's catch you at the very beginning. You can catch it after that in code review if you've got another engineer who says that doesn't look like a great idea, or maybe you catch it in testing or production. But overall, there's this sort of traditional good to bad trend in which like you want to catch issues earlier up the stack. I've seen it commonly discussed that things kind of end on the badness scale at the bug bounty report kind of stage, but it actually gets like much worse than that. So I'm at Facebook now. I was at Twitter in the early days. I was at Microsoft before that. So I've seen a lot of stuff in production over my career. And there's also these additional things I'd like to add where you get like a responsibly disclosed external finding. So this is somebody that doesn't work at your company, but they found a security bug and they tell you about it. You don't have a bug bounty in place, and so there's not really any incentive for other people to tell you about the same thing if they find it. That could lead to these following two things, which is like, you check your Twitter feed or you turn on the TV and it's like, oh, your company is being hacked right now. The nice thing about that is that you know about it, and so you can go do something about it. Which brings me to this last bit here, right? Like if active undetected exploitation is going down, you don't actually know that you're being owned and you are totally blind to what's happening. You'll usually find out about it later on, and then you've got a whole lot of cleanup work to do. I try to put everything in perspective. Like, so I walked here, I took the muni and everything. Like, there's a lot of actual bad stuff going on outside the world of like cross-site scripting and stuff. So one of my asks every time I get a microphone is like, you spent 2 days here, go spend another 2 days working in a soup kitchen or give some money to some people that need it and stuff like that. But that's just because they gave me a mic for 30 minutes, I get a chance to say that. Bringing it back to the world of security, though, we'll kind of operate on this scale of like, okay, it's good to catch things as early as you can, and things get worse and more severe as they go down the stack. And there are tons of mappings for how bad a security bug is that exist in like open source projects. We've got Chromium, Red Hat, Drupal, they're all over the place, and you probably have some notion of like bug severity in your development. But so you can map these numbers to the severity that you're using already. So I also care about only the most severe things. You should have a class of issue that's so bad. You can call it like an incident or a site event or a bulletin or something like that, but something that goes beyond the scope of security. So like if the whole entire website is down or you've lost all your billing data or something like that, like that's impactful for more than just a security reason. So there are mappings from overall things that are really terrible to security things. And I like to use only the issues that are so bad that they're up into this like incident level issue. So that gives you some data, right? So you can write a script that'll pull from your bug database or your incident management thing, and you can suck out some data. So this is not Facebook data, but this is data that I have somewhat manufactured, somewhat gleaned over time. And this is like what it looks like over a couple years, quarter over quarter. The most severe issues mapped down to the least severe issues that are still pretty bad. The one thing that I'll note about this model is that it doesn't account for the unknown unknowns. So I like to call this Schrodinger's security bug. So there's this phenomenon of Schrodinger's cat. Excuse me real quick while I drink. You can admire the cat. But there's a security bug in the code, and it never gets detected or never gets exploited. Is this good or bad? I would argue that the data eventually catches up. So when this does get exploited and you do find out about it, or you find it later on through some additional testing that you've done, it'll play itself out in the metrics, right? So if you had an unknown bug that you come back and find later, you'll have a severity of like 0 or 7.1 type issue that you can then account for in the current quarter's data set. So that's cool, but like nobody ever takes a selfie and just like posts it raw, right? You gotta like apply all the filters, you gotta do like the dog ears and the bunny rabbit stuff on there. And so if you just have this big collection of data, you can't really do too much with it. Although you can just like total it all up, right? And there's a prerequisite here throughout all of this pitch is that you have like objective honesty. So the incentive isn't to get all your developers to sweep their bugs under the rug and not say that anything's a sev. you do want to like continue reporting bugs, and you want to encourage all your teams to find bugs in the software that they're writing. So don't say that like, our number one goal for the half is to have no issues reported, because then nobody will actually report any issues. Like, you want to set that goal that like we'll work towards there being no issues in our code base, but we realize that we're going to have them and we should always report them when we do. And so this is if you take that data from the previous slide and you just add it all up, you get this purple line, which shows you like, okay, things kind of got bad for a little while there, and then they seem to be getting a little bit better. It doesn't account for severity or anything like that. And so that's why my second kind of hypothesis here, something I'd love to give back to the world, is this formula which makes it exponentially bad for the worst things to happen than the things beneath it. And I'll talk towards this a little bit with the data, but so every Sev 0 now becomes something that's like 27 times worse than a Sev 3 issue. So you get this really, really big spike, and this encourages you to work on only the most impactful things that are the worst things that are happening in your code base or in your system. I bounced this idea around a few people, some of which are Dr. Matthew Nifter and Dr. Charlie Miller. So these are like PhDs in computer science and mathematics, respectively. And they're like, yeah, cool, like algorithm you got there, man. But just like sum it all up and I'll show you like the numbers. Instead of my crazy exponential badness, things just get like step level worse as you go up the scale there. And so I didn't expect people would like be like, oh yeah, it sounds kind of interesting, and just like go implement it themselves. If you check out this bit.ly link down here, it is a link directly to a Google Doc that has all these like stupid equations in it already, and you can just like do file, copy, and plug your own data in here, and then you'll kind of see how you're doing over time. And so this is like, go check it out, see how you are doing over time, and if the work that you're doing is actually paying off. So I had this other part of the abstract about incentivizing long-term secure framework bets. And this is a little bit about how you do that and why you should do it. So whenever you have a security bug come in, or it can be like an architectural flaw or anything like that, like you're working in the security space, you should ask these 4 questions about like what happened, why did it happen, like what failing was there that led to this issue occurring, when in the development lifecycle did it happen, and then where, like what code base or what system or what part of the environment did it happen in. And that should then inform you and allow you to work less on the reactive stuff over time and then more on the proactive and mitigating stuff. And so this kind of maps back to my little wacky data set I had before. Maps here. It was like back in the day, maybe we didn't have a lot of users, we had no security team, maybe we didn't know what we were actually missing. It was kind of like chill times. And then the company started growing, and the code base started growing, and the user base started growing, and so security vulnerabilities just started like trickling in. They were always there, but they're just starting to get noticed. Typically, somebody will find like one issue, and that issue is all over the code base. So you have tons and tons of repeat classes of issues over and over again, hopefully not for a super long time if you can do some work to prevent it. So there's this HTTP header that every big browser will honor now called content security policy, and you can kind of set this on your HTTP responses so that you'll neuter XSS exploits, right? So we get there, we still care about XSS, but what we've done is this engineering work to like dilute the severity of every cross-site scripting issue. And then you can move on and like change your tech stack or work on core fundamental like foundational work so that you'll get auto escape templating. So you can move over to something like Mustache, Handlebars, anything like this, where now the developers don't actually need to be thinking about security every time that they're building their code. It's happening by default, and then you've like accounted for all these terrible times that you've had in your life when you were getting paged nonstop in the middle of the night, or you check Twitter or like the full disclosure list and you see that you were the #1 issue there all the time. And this is just a way to, it's a trailing measurement, I recognize, but basically incentivize yourself and your whole entire team to make things less bad in the code that you're working on. One thing that I'll recommend as like a bit of my pitch here, and a thing that might be easier and more effective than you might think, thank you, is this notion of non-obvious APIs. So like developers are sitting down to write code and they don't necessarily know what they're getting themselves into. And something that you can do as a security engineering team of these giant sweeping code mods. So you go back and let's say that you've got maybe 10 different code repos that have the code that powers your company's systems and all these different code bases. I would recommend taking this approach to basically make it safer through the engineering team coming in and making it more obvious when you're writing code what you're getting yourself into. So has anybody here worked with Django and want to tell me what SafeString does? And if not, I'll tell you, but I'll give a moment of silence for somebody to shout it out. That's cool. So I also got the documentation to tell everybody what it does. What's confusing here is that it's called SafeString, and what it does is it takes a string and it marks it as if it's been already cleaned and is safe then for further display. And like I heard some gasps in the audience and stuff like that. It's just confusing, and maybe it's actively misleading developers. Like you go down, you're about to work with something, and it's like a safe string, which means this is actually dangerous. All you have done is tell it that you know that it's safe. So it doesn't make it safe, it marks it safe. And it's confusing enough that I've seen enough cross-site scripting bugs in Django code bases as a result of the developer going in, explicitly marking something as safe because they think it will make it safe, and then it leads to a cross-site scripting bug on the site. Less misleading but still confusing is this syntax here. And so I mentioned the auto-escape templating being a really great thing that you can apply to your code base so that you don't have to remember to escape untrusted user input all the time. So Mustache has these semantics that will allow you in your templates to specify that something should be unescaped when it's rendered. So this is the same as marking it safe. You're building out a template for rendering some data back, and you say, I know that this is going to only contain like bold and italic tags. It's not going to contain anything nasty because say that I'm building it out myself. The issue here is that a lot of times in big engineering firms or even a small engineering team, you're going to succumb to a time when you want to get something done. And the easiest way to get something done is to look at how somebody else already did it in the code base. And so you'll go find a template for like displaying somebody's company name that's always set. And you say, okay, well, this is how we did it this one time over here. You're going to copy that, paste it into your file, and then lose this assumption that the code you were working with before and the data you were working with before is actually safe to display, and you're going to end up with another cross-site scripting bug. So one of my favorite things about working at Facebook is this Facebookism, where we're pretty obviously in your face about not necessarily wanting to call a particular API or method. So if you can't read this, it's called secret DOM, do not use or you will be fired. This is in the React code base that we've open sourced. And I can honestly say that like when I joined Facebook, I didn't know necessarily what was going on with this code, but I was not incentivized to call into these methods, I'll say, right? Like I stop and I pause for a minute, and a lot of times we'll talk about education being the solution to all our problems, like only if we had smarter developers we'd be so much better, and if we invested in all this training we'd be so much better. One of my beefs with that theory is that there's so many things that you need to have top of mind when you write code that needs to scale at like Facebook scale, or even just code to run anywhere, right? So you need to keep like performance in mind, and internationalization, and accessibility, and scalability, and interop between old services, and security, by the way. And so it's really a pretty heavy cognitive load on somebody sitting down to like think like safe string, that makes it safe or marks it safe? Like it's kind of tough. Whereas this thing is like way more in your face about don't call this, or if you're gonna call it, like think twice about it. And we've done this. So our contextual auto-escaping library is called XHP. It's built on top of like PHP code. And if you want to do something where you'll actually like disable the contextual auto-escape we have, you have to mark something as like, oh, potential XSS hole. And so that's the only way you can do it. It's in your face, and you're not gonna trip into this most likely. And if you do, we've got a security team that kind of like passively watches all the code that's flying through and can match, like do pattern matching basically on diffs that are submitted and say, oh, this looks like something that you probably shouldn't be doing. And so one of our helpful product security engineers will jump in and kind of ask a little bit more about why it looks like you're calling into a particular function that you probably shouldn't be calling into. Similar in that React code base, we also have dangerously set inner HTML. So If you're doing more like JavaScript development, you're working on the client side, it's easy to introduce DOM-based XSS by setting user data explicitly to inner HTML on an element in the DOM. And so we never want to neuter the platform or like handcuff our engineers so much that they can't do the dangerous stuff if they really, really want to do it. So we've got this notion of like dangerously set inner HTML. Again, this is the only way you can do this. It says dangerous right in the title. Hopefully you know what you're getting yourself into when you do this. And so we can kind of hypothesize that this is a good idea, but everybody's like, show me the data. I want to see data that actually verifies that this works. And so an exercise that we did most recently is, Facebook's done a really pretty good job at eliminating the traditional OAuth top 10 stuff. So like cross-site scripting, cross-site request forgery, SQL injection, all that. Like if you find it, please tell me about it. Submit it to the bug bounty. You'll be rewarded handsomely for doing so. But logical issues are kind of tough to catch through static analysis or have every developer really appreciate when they're like building out their prototype code. So we had this model where instead of permissions being applied at like the viewer layer, or like, you render the page and the page checks if the person viewing this data has actual permission to view the data, it's plumbed all the way down to like the object itself. And so when you're setting up an object for like a birthday, you kind of like specify what can be done as far as like read, write, updates, delete on that object itself. So we could say in the beginning like no permission. And what we found is that similar to SafeString, it was confusing. Like, does this mean you don't need any permission to do anything? Or if you have no permission, then you can do everything? And so we renamed this, again, one of these like big sweeping code mod things, to anyone on the internet can modify. And we're like, this is a little bit more obvious and in your face when you do this. And so I mentioned this tool we have for checking out every diff that comes by. So basically every patch that wants to be submitted to our main code base. And we were like, well, let's like try measuring this thing and see if it's working or not. So in the past, we would always look at every time that somebody was using like this no permission attribute. And we'd say, hey, do you really want to be doing this? And we'd go in and we'd go back and forth and clarify if they really wanted to do it or not. And so I'm always in the business of like engineering myself out of a job so I can go do something more interesting than my current job. And so jamming back and forth on these no permission diffs like wasn't super interesting. We had this idea like, oh, let's rename it to this more obvious thing. And it seems like things are trending down there. So there's also a couple blips to explain in this data. We do like biannual performance reviews. And so in July and December, everybody stops writing code for like 2 days and they write their reviews. And then they come back up and they like crank out a whole bunch of code that they've been sitting on for a few days. So those are those two dips right there. And it seems to be working. So maybe when I write all this stuff down in a blog post someday, I'll give you the thrilling conclusion as to like whether or not this thing worked. But let me add two more things that I think are important. And like I said before, with the dangerously set inner HTML, you never want to just be the security bad guy team that tells take everybody's toys away and never give them back. So we found in like going back and forth on these diffs with people, why they were doing it is that they really just wanted to move fast and iterate quickly and not think about this complex privacy model when they were just prototyping stuff. And so we were like, oh, cool. Like it's kind of a missing feature that we don't have anything that will run in like the development environment with everything like totally wide open so you can jam on it, you can work with design, you can do whatever you want to do, but it's never going to make it to production with this wide open model. And so we like introduced development only, and we saw people picking that up more and more. And then after that, I saw in the DevOps talk or a few other talks, like it's true that there's no place quite like production, right? Like you've got different systems there, you've got real user traffic, you've got all these other things. So we also allow people to ship stuff to production with an employee-only attribute. So that means that you can get stuff in our real production environment, and you can dork around with it in employee-only mode, but we're never going to put any like real user data at risk because everything's going to fail close all the time. Lastly, I'm bringing it on home. I got a couple minutes left here. The selfie taken, never shared is like a total waste of selfie. So my pseudocode pitch here and some embarrassing whiteboarding that I'm happy to share with you all, though, is that once you get all these bugs, you can pull in, so this is some janky PHP or hack code that looks at this collection of bugs that we've got. It pulls from a particular tag, right? So let's say we tag all our security bugs with 31337, so we know that they're security bugs. We'll initialize all these maps, so like a map of all our employees, recursive employee map, I'll get into that in a second, a map of the team and the office, and so we load all these things in. Then for every single bug, we'll add to or increment, if it's already in there, one of these owner objects to the map, right? And so now we've got this big giant map of everybody that's ever written a security bug in our engineering team. We also do a recursive fetch for everybody in their reporting chain so that we can say like, hey, this VP over here is responsible for 90% of the security bugs in our code base. Let's go have a conversation with him or her. And then after that, you can get stuff like office location. Maybe we need to go send an engineer to Seattle for a couple weeks, or particular code base or anything like that. So grab this data. Lastly, I'll caution though that there's this fantasy maybe of there being one rogue developer somewhere offshore that's like responsible for all your security bugs. I think if you do this exercise, you'll find out that's not the case. At one point, we were looking at a particular set of bugs, and we were like, who's responsible for all these stupid security bugs? And it was like the security team going in, trying to fix up other bugs that were like lower priority, and it was kind of like, you know, bull in the China shop thing, where they're just like kicking over, making a big mess, and so we were like, oh, we're going to get those rascally developers, and it was all us making those mistakes. And so you'll sometimes find that this is kind of like the equivalent of like looking in the mirror, and you'll see that you yourself are responsible for all these issues. So a little bit of a call to action here as I wrap my 30 minutes up, and I think I've got time for questions. Take this, like apply your own data, and then like let me know how it's going. I think that this meme was relevant maybe 6 months ago when the Yo Gotti song came out. Now I think it's more catch me outside. How about that? If you want to have a conversation. Because I really do think that it would be great to jam on this as like a collective industry, share the results, and then, like I said, incentivize these kind of long-term bets so that you're not spending all your time doing reactive firefighting. I think that the heroics that come along with that are great, but they're also exhausting. And it's much better to, be able to have a chill Friday, Saturday evening. You can go sit down and read the BSIM with your whiskey and cigar, rather than like hot patching production systems and stuff like that. So that's all I've got. I'm Jim, like I said, Jimmy O. I also have yet to regret telling an audience full of security people that I have enabled the option to say like accept direct messages on Twitter from anybody, whether or not they follow me. So you can hit me up on Twitter anytime, catch me around here, ask me questions. I'm gonna take a selfie because it's the name of the talk after all. But in the meantime, I'll try to navigate this room despite the blinding light in my face to answer questions if people have them. And if not, I think we've got another speaker in 7 minutes. All right, well, I'm going to pull this one off real quick. Smile. All right, cool. Thank you all.
Thank you, Jim. So on behalf of Fitbit and BSidesSF, we'd like to present you with a Fitbit Alta, where motivation is your best accessory. So